the last thing from 4.1. So what we want to always do when we add and subtract is I always have to have enough numbers, right? That's why they have to be the same size. Well, the following two matrices have the same number of numbers, right? Entries. They have the same number of entries. Matrix A has 6 numbers. Matrix B has 6 numbers. However, they aren't the same size. Matrix A is a 3 by 2. Matrix B is a 2 by 3. And so the answer to the question is, can I add matrix A to matrix B? As they stand, the answer to that is no. Because this one, matrix A, has an entry in 3, 1, but there is no matrix B 3, 1. Unknown, right? Does not exist. And in B, I have a 1, 3, but in A, I don't have a 1, 3. It does not exist. And so I can't add, as they stand, I cannot add A to B. But, as mathematicians realized, if I just reorient them a little bit, if I change one's rows and one's columns for one of my matrices, I then have enough numbers because they both have 6 digits. And so what mathematicians developed was a process to change the rows and columns. And so that process is called a transposition. Alright, so transposition is literally that. You're going to transpose the matrices. You're going to flip the row and the column. So if matrix A had m rows and n columns, when I do transposition, and it's denoted A raised to the T, capital T, what you're literally doing is you're going to take row and column from matrix A and you're going to flip them. Right? So we'll do that up here on this matrix A in a second. So I'm going to erase this. And so whatever was a row becomes a column, whatever is a column becomes a row. And you always write in order. Right? So matrix A transposed is an n by m, right? Flipping n and m. The rows in matrix A become columns in the transposition, and when you rewrite them, you always rewrite them left to right. So what was in row 1, the numbers going from left to right, becomes the entries in column 1 of the transposed matrix going from top to bottom. And I'm going to do that in A. So I'm going to take my matrix A and write its transposition. Alright, so remember, matrix A was a 3 by 2. Rewrite all of this. So my matrix A had 3 rows by 2 columns. When I take my matrix A and do the transposition of it, it should flip that and become a 3 by 2. 2 rows and 3 columns. What was row 1 becomes column 1. What was row 2 becomes column 2. And so when I do my A transposed, this row 1, this row 2, this row 3, becomes column 1, column 2, column 3. Alright, so row 1 was 2, negative 5. Well, that becomes column 1, 2, negative 5. What was row 2, 0, 3, becomes column 2, 0, 3. And that's what they mean by, when you read the row, you read it left to right, right? 2, negative 5 comes the column top to bottom. The 2 is on the top, the negative 5 is on the bottom. And the same thing for the last row. Row 3 becomes column 3, negative 4, negative 7. Alright, I'm going to go ahead and do the B transposed as well. Alright, so there was A transposed. Well, suppose I want to transpose B now. Alright, so there's the A transposition. And A transposed is a 2 by 3. Well, now let's do B. Alright, so B transposed. So B is a 2 by 3, which means B transposed would be a 3 by 2. What was row 1, right? This is row 1, will become column 1. So reading right to left, so 5, negative 9, 2 becomes top to bottom. So it goes 5, negative 9, 2. And then row 2 here becomes column 2 there. So 4, negative 6, 1, right to left, or left to right. top to bottom goes 4, negative 6, 1. And there's B transposed, right, which is a 3 by 2. There is a location of this on the calculator. If you look under the matrix key of the calc, if you remember, the matrix key is that X inverse has above it matrix. If you go over to the calculate part, where we found our REF that was all the way down on the bottom page, your calculator can't do this if these are just numbers. If you go over to your matrix, right, you've got names, not calculate, sorry, names, math. Go over to the math. And so if you scroll over to math, you look at the number 2, it's got that capital T in it. So your calculator can do this. It is on the calculator. I'm going to do it by hand because you, again, will throw letters at you where you can't plug it in the calculator. But you can do this on the calculator. You can check my answers on the calculator. Where you find the transposed is you go into the matrix, right? You have to hit second, the X to the negative 1 to get to the matrix, go over to math, and then it's the second one listed on the calculator there. Right, I'm going to do it by hand. So A transpose, which we already had. Alright, so I'm going to write down my A transpose. So if you remember, A transposed was 2, negative 5, 0, 3, negative 4, negative 7. Add that to my matrix B, which was 5, negative 9, 2, 4, negative 6, 1. And then I can add them, right? I can take A transpose because now they're the same size. And so I just added the like spots. So again, just make sure you're careful when you add. So 7, negative 9, negative 2, negative 1, negative 3, and negative 6. And we add them. So there's my A transpose with B. And then the last one. So I'm going to rewrite this as A plus negative 1 times B transpose. And so my A matrix, I'm going to write down. If I find my A matrix. So 2, 0, negative 4. A little bigger than what I have. 2, 0, negative 4, negative 5, 3, negative 7. And then instead of subtract, I'm going to add the opposite of B transpose. Alright, so my B transpose was this. The opposite of that would be basically whatever was a positive becomes a negative, whatever a negative becomes a positive. So it's going to be negative 5, negative 4, negative 5, negative 4, positive 9, positive 6, and then negative 2, negative 1. And then you add. Alright, so just make sure you carefully add. So negative 3, negative 9, a lot of 9s, and negative 8. And so there is my A minus B transpose. Which again, you could plug it into the calculator and check it if you want to. Alright, the last example is basically an example of putting it all together. Alright, which usually what they'll do on the test is ask you this. Now I ask you to find all of them, but probably on the test they'll just ask you for. So this would be, again, the kind of question they'd ask on a final exam or the quiz for this class, for this section. Is this question has addition, transposition, subtraction, and scalar multiplication all in one question. Right? Where if you look at these, they all have letters in them, so you can't plug them into the calculator. So this is sort of putting it all together. And I'm going to find the entire matrix M, but like I said, on the test, they probably only ask you for one, like M21 or something along those lines. And I'll talk about that more once we find it. Alright, so I'm going to rewrite this, so I want to find M. And so I'm going to write down my E, it's just E as is, so I'm going to write down E. So E, if I rewrite that carefully down here, 0, 2, K, negative 7, 4. The biggest mistake I can make at this point is mistyping something. Right? D transpose, and I have to do D transpose because I can't add D to E if it's not transposed. And so remember, what was row 1 becomes column 1. So row 1 was negative 4, 3. Well, that becomes column 1, negative 4, 3. Row 2 is 5D. Becomes column 2, 5D. Row 3 was negative 2, 1. Becomes column 3. And then the last thing I'm going to do is I'm going to change this to plus negative 2 times C. So I'm going to add, taking my C matrix and multiplying it through by a negative 2. Alright, so again, that's what I'm going to write over here. So I'm going to get negative 8, negative 4, positive 2, 0, positive 6, and negative 2 times C, which is just negative 2C. Alright, so there is my E, my D transposed, and my negative 2C all written out. Alright, and once I do the math, that'll give me my matrix M. Alright, so remember I can only add like things together. So the first one is 0, negative 4, negative 8, and so that's negative 12. K, there's no more K's, so K comes down, but I add to it 5 and 2, so 7. K plus 7. 4, negative 2, 0 gives me a positive 2. 2, 3, which is 5, negative 4, so that comes out 1. Negative 7, D, and 6. So D is just D. It's going to come along, and then I take care of my things I can add, which is the negative 7, 6. That comes out negative 1. 5, 1, negative 2C, so negative 2 plus 6. Which if you did those in different orders, that's fine. So if you'd written this as negative 12, 7 plus K would be fine. Or negative 1 plus D, or 6 minus 2C. Again, all those are exactly the same. All I did is rechange. So again, those are all M. Right? Either one of those are fine. Alright, so there's the entire M matrix where, again, I did a little one of everything. I did a addition, a multiplication, a subtraction, and a transposition. And that's the entire matrix. Now, on the final and probably the quiz, just because it's easier to type out instead of... It's harder to type out an entire matrix. So what they'd probably do is they'd probably ask you for probably one of the ones with the variables in it. So they'd either ask you for M1, 2, which would be K plus 7, or M2, 2, which would be D minus 1, or M2, 3, which would be our 6 minus 2C. One of those would probably be the... Actually, probably one of you would get one of each. Again, if they do multiple types of the same question, is somebody would get the first one, somebody would get the second one, somebody would get the third one, right? And then that would be your answer. You'd only have to give... And so you'd only have to find those. You wouldn't have to find the entire matrix if you didn't want to. So you could... So suppose it was M1, 2. Right? That was the one that was asked for you to find. And so instead of finding the entire matrix, which you could have done... Well, M1, 2, I would just take the M1, 2's of all mine and just find that single value. Instead of finding the whole entire matrix, we'd only find the ones in row 1, column 2. Right? That's what M1, 2 is. And so then you just find your K plus 7 and you'd be done. And hopefully that makes sense. If not, if in doubt, find the entire matrix and then find the part that you're looking for. All right, so that finishes up 4.1.